this video, I would like to explain the API Gateway Monitor based on Elasticsearch. In principle, it works like so that instead of that the API Gateway Traffic Monitor, that web UI you will see in a minute, is normally calling the REST interface exposed by the admin node manager, and that REST interface is communicating with the so-called OpsDB, which is located on each API Gateway instance. When using the Elasticsearch implementation, as you will see in a minute, the API gateways are configured to write out the Open Traffic event log, which is then processed by Filebeat, forwarded to Logstash, and Logstash is forwarding it to Elasticsearch. And an API builder is exposing exactly the same API as the admin node manager, but in that case, based on the data in Elasticsearch. Not used as part of the demo is an alternative approach called the LogSpector instead of the API Gateway Traffic Monitor. So let's see how that looks like. For that, I have configured an API management setup like you see here on the screen. So that means I have one group which is enabled with an API manager, and it has processed over the last 10 hours about 5.3 million API requests. As you can see, it consists of 6 API gateway instances. Each is running on a different AWS machine, and each machine is equipped with 4 virtual CPU cores and 16 GB RAM. And the Filebeat is running itself on that API gateway instance together with an API builder mock service that is mocking the APIs you see here, how they are called. The current implementation, so that means what is actually supported by the API Builder REST interface, is what is behind that traffic monitor. So I'm actually on an admin node manager, which is still using the OpsDB, while this admin node manager is using the Elasticsearch when entering that traffic monitor area here. And now let's play around with that traffic monitor. When looking for the current data for the current API request of the day, it takes a time, but it's still okay. You can work with. It takes almost the same time to get the data from Elasticsearch. But in reality, you do something more sophisticated. You, for instance, would like to get APIs that have a duration about 150 milliseconds. Let me reduce that also here to 200. Maximum request, because these servers I'm using are located in the United States and I'm based in Germany, and due to that I would like to avoid to transfer too much data from the US into my region, and this will slow down the processing or displaying the data on the screen. So now I have just changed the duration and show me only APIs that are greater than 150 milliseconds. And I know now that takes long. So that's why I can go to the API Gateway Monitor based on Elasticsearch. I can say, give me the duration 150, 200, almost everything is the same and the data is just there, while it's here on that side still loading. I can continue on the Elasticsearch instance and I can say, give me, for instance, a specific API and say, like, not that one, like pet store, find pets by status. I would like to see only that API and on the screen right there. While the other one has now loaded it, and I can try to do the same and say, give me the path. And this is find by status and fire it. And now go back to Elasticsearch. And also the API details are implemented by Elasticsearch. So that means all the data you see here now on the screen are driven by Elasticsearch, including, as you can see, request, response, and if an API has some trace information attached, you will also see the trace information belonging to that API. So that means the same user experience like for the OpsDB. Just check here. This one has just finished loading. And now let's do a little bit more sophisticated and say, or not more, but let's say a different one and say, I would like to get the APIs which have a status of 401 and the execution time should be greater than 150 in the actual day. And let's do the same over here. The duration we already have and the status should be 401. and then we find one API which is in that range, which obviously had a communication problem. And in that case, you already see how the trace information is attached to that API. Okay, and this one here is ending up with no results. And this is not because the data is not there, it's just because the request to the node manager has timed out. Now let's have a look how fast that reacts. I mean, is it really real time? For that, I would like to send a request to my system, and I'm calling the health check, just very simple, on that AWS instance on one of these, and it's 10 p.m. This is the request. It takes a moment to get the data transferred, but let's check for the health check and say apply. And yeah, the data has been processed already. So that means we see that the health check is there, and we can send another one. Sometimes it takes a little bit longer. So that means I would like to try that out. So now the other one has arrived as well. So I mean, that's acceptable. It's actually configured to have a maximum delay of 10 seconds if there's absolutely no queue. Okay, and that's basically everything I wanted to show. Thanks for watching.